Good evening, everyone. This one is January 2016, Unit 5 of IAL Physics, old specification. The first question, the brightness of a star depends on luminosity, and so we have this formula that flux is equals to power per unit area or luminosity divided by area, and area is equals to 4 pi d square, where this d is the distance between the source and the observer. So it depends on the luminosity. It also depends on the distance between the source and observer. That's why B is the right answer. In question 2, a mass is hung from a spring and set into vertical oscillation. The amplitude of oscillation half after 10 cycles. The ratio of total energy of system at the start and total energy after 10 cycles. So we know the energy for a system vibrating, it is given by half kx square. So original energy is E, but after 10 oscillation, because the amplitude of oscillation is half, so E is equals to half K, so it will become x by 2 whole square. So when we solve, it will be 1 by 4 because 2 square is 4, half kx square. So this is energy from the beginning, at the beginning. So we can say E is equals to 1 by 4 of E dash, where half kx square is E dash, the original energy. So when we compare the ratio, because we need a ratio, the energy in the beginning was E, and energy after 10 oscillation is 1 by 4 of E or E dash. So when we simplify this, so it will be 4 is to 1, as this 4 will be multiplied there. So the correct answer is D. Originally, the ratio of total energy of system at the start to the total energy at the end after 10 oscillation, 10 cycles, that is 4 is to 1, or we can also say 4. Question 3. In question 3, a radioactive sample is there which is having a known half-life. Radioactive decay is a random process. What is the meaning of random process? When when a given nucleus will decay, we cannot predict the time for whole sample to decay. That also cannot be done. The next nucleus will decay because it's a random. The term random means fraction of a sample that will decay in 1 second. That only we can predict. Like in next second, what fraction will decay, but we cannot exactly say when a given nucleus will decay or time for whole sample to decay. So we can work out its activity, but we cannot say anything about when the next nucleus will decay, the time for whole sample, as well as when a given nucleus will decay. But fraction of a sample that will decay in 1 second, so we can work out or state its activity. In question 4, the average density of a universe is unknown. The scientists believe that there is a critical density value for this. Scientists believe that there is a critical value of this density. If the density of the universe is less than the critical, so if density is less than the critical one, so we don't have enough gravity to hold the particles together, and it will continue to expand forever. But if the density is higher than the critical, then it will be a big crunch, and if it is equal to critical, then it will continue to expand. After that, it will reach a certain size and stop expansion. These are the three phases of the universe. Energy is supplied to a fixed mass of a gas in a container, and the mean square speed of a gas is doubled. The absolute temperature, we know kinetic energy is directly proportional to temperature, and kinetic energy is half mv square. So what we did, the mean square speed means this whole factor is doubled, not v. This whole factor is doubled. So if this whole factor is doubled, kinetic energy will be double. If kinetic energy is doubled, the temperature will also be double. That's why C is the right answer. A radioactive sample is a beta emitter. The beta particles are able to pass through air only. They can pass the thick card. They cannot pass through aluminum, or they're able to pass through a thick card as well. Not only air only, but not through aluminum or lead. That's why B is the right answer. If it was alpha, then it can pass through air only. And if it's gamma, then it can pass through aluminum as well, thick card, as well as air. The figure shows our sun spotted in Hertzsprung-Russell diagram. Once hydrogen fusion has ceased in its core, the sun will move to a new position. So the sun will turn into red giant when the helium fusion will start, and this is a position where we'll find the red giant. So the correct answer, the new position of the sun, it will be B. A piece of chocolate is heated at a constant rate. The graph shows how the temperature of a chocolate varies with time. Select the correct statement for time between x and y. So what happened between x and y? The internal energy of a chocolate is increased. Internal energy is a sum of potential and kinetic. Kinetic energy remains same because the temperature is constant, but when we supply energy, potential energy is increasing. So the internal energy is also increasing. Why not B? The internal energy of chocolate stay constant. That's wrong because the potential is increasing. The kinetic energy does not change, so that's also wrong. Potential energy between the molecule and chocolate stayed constant. That's also wrong. The graph shows how acceleration varies with time for an object undergo a simple harmonic motion. So here the acceleration is a function and of sine. So A is sine. And acceleration and displacement for object undergo simple harmonic motion are directly proportional but with negative sign. So which one should represent the graph for displacement? So displacement graph should be minus sine. So which one is the graph? Choose variation for displacement. So minus sign, it's B. So that's why B is the right answer. Choose a graph that shows a variation of velocity. So we have a displacement graph which is minus sign. So when we take a derivative of sine theta, that's cos theta. But this is minus, so it will be minus. Derivative of sine theta will be cos theta. So the velocity is represented by minus cos theta. So the graph which is minus cos theta, that is because this is a graph for plus cos theta. This is a graph for minus sine theta. This is a graph for minus cos theta, and this is a graph for sine theta. So it should be minus cos theta. So C is the right answer for question 10. So this was January 2016, Unit 5 of IAL Chemistry. Hope you enjoyed and liked this video. Subscribe to the channel.